Hello and welcome students. We are starting today with onto function. I will teach you what is an onto function. You already know what is an one function. So if I want to revise what is an one function, you will say that one function is a function in which every element of the range set has one and only one pre-image. Like -6 has only one pre-image, -3.4 has only one pre-image, -1 has only one pre-image. So when the elements of the range set have one and only one pre-image, we call such function as one function. We are now going to see what is onto function. So before that, let me tell you something about this function. This function here, which is denoted by f, what is the function? The function is every number from the domain set is doubled and you get the range set. So if that is the function, if I write the elements of the domain set by variable x and the elements of the range set by variable y, then the function is represented by y equals to 2x. The function is represented by y equals to 2x. Moreover, there is one more way of writing the function, which I also explained in the previous video. You can write here function f from R to R. Now when I say R to R, what I mean is the domain is set of real numbers. See here I have written capital R. This represents that domain is set of real numbers, and the range of this function is also set of real numbers. You see this first R is a domain and this R is range. So both are set of real numbers. Now, why is this happening? You have to understand the domain of this function y equals to 2x, where f of x is 2x, the domain is set of real numbers because you are able to get the double of every real number. See, the function is f of x equals to 2x. You know all those numbers which go to x, which you can put in place of x, are the domain numbers. So I want to ask you, do you think any number, do you think of a number which cannot be multiplied with 2? Is there a number which you cannot multiply with 2? No, you don't have any such number. All the numbers can be multiplied with 2. That is, all the numbers can be doubled. So all real numbers are permissible for doubling. Since this function f is applicable on all the real numbers, hence the domain of the function is set of real numbers. Furthermore, if I say that if the domain is set of real numbers, what will be double of these real numbers? What will be double of these real numbers? The double of all the real numbers will again be real numbers. May it be integers like -3, 0, 1, 2. May it be decimal numbers like negative of 1.7, negative of 0.5. May it be irrational numbers. For example, √2. If I have √2 in the domain, then remember students, here I will have 2√2 in the range. I hope you are getting it. Now I ask you a question. The question is, look at the codomain set. What is codomain set? In last lecture, in the last video, I taught you codomain set is a set from which the elements of range set are coming. If the range of this function is real numbers, then what if the range of this function is set of real numbers, then where are these real numbers coming from? The real numbers are coming from set of real numbers. Hence, the codomain of this function is also real numbers. Now, if I ask you, here I have got a real number. If I keep a real number here in this box, may it be any real number. So so do you think this number will have a pre-image? Do you think that this number will have a pre-image in the domain set? My question to you is, if I am writing a real number in the codomain set, in this set, if I am writing a real number in this box, so will there be a pre-image for this real number in this set, domain set? The answer is definitely yes. The only thing will be this number will be half of this number. Okay, so if I call this one as say any real number, let it be alpha. So if I have alpha in the codomain set, some real number, then I will definitely have alpha by 2 here as the pre-image, because every number from the domain set gets doubled to get you the range set, the range set. Hence, what I can say here is every element in this codomain set, what I can say is every element, try to understand, every element in this codomain set will definitely have a pre-image. Every element in the codomain set, if I have an element here, then definitely it has got a pre-image. No doubt it has got a pre-image in the domain set. Every element has a pre-image here. So what I understand is, in this codomain set, no element will be left out. No element will be left out. In other words, you can say that all the elements of the codomain set are used up. All the elements of the codomain set are used up. Now, when such a case happens, you call such function as onto function. Such function as onto function. So here I read the statements. Please follow what I am reading. Here we notice that for every real number in the codomain set R, there exists a pre-image in the domain set R. Hence, in the codomain set, all numbers will become the members of the range set. Here, the codomain set is equal to range set. So in this function y equals to 2x, you notice that codomain set and range set are equal. They are one and only one set. Codomain set and range set, they are equal. So we will define the onto function. A function is said to be a onto function if the codomain of the function is equal to range of the function. If the codomain and the range are equal for a function, then such a function is known as uh, an onto function. Now, to explain this, to understand this much clear way, I will teach you in the next video into function. Once you understand into function, then you will be able to understand, then you will get a proper idea about onto function. So here, students, what this function was? This function was an onto function. In the previous video, this this function y equals to 2x, in the previous video, this function y equals to 2x, we had already seen that it was an 1 1 function. I had already explained that y equals to 2x is an 1 1 function. It is the same function y equals to 2x. y equals to 2x. So we had seen that this function y equals to 2x, where f is from R to R, was also an 1 function. So now combining this concept with the concept that I just taught you, we can say that y equals to 2x is an 1 on 2 function. It becomes 1 on 2 function. In the next video, I will teach you what is an 1 into function. I will teach you what is an 1 into function. So now the idea about 1 onto is very much clear. You know what is 1 onto function. This function is 1 as well as onto function. It is 1 function because every element of the range set has one and only one pre-image, and it is onto function because no elements in the codomain set are left out. Every element has a pre-image in the domain set. Thank you. You can replay the video and understand.